Ever get annoyed waiting for like your phone to translate something?
Ah,
Or I had a chat bot that
yeah,
just seems so slow.
totally.
Like, what's the deal with that? It feels like even with all the advances we hear about in AI, they're still held back by like one big thing, and
Yeah,
that's just speed.
you're absolutely right. It's a bottleneck we've been dealing with for a while now. These large language models, LLMs as they're called, they just require a massive amount of processing power, especially if you want them to work in real time, for those applications we were just talking about.
Okay, so the more complex these models get, the harder it is to make them run smoothly,
hmm
especially on something like our phones, which don't have, the power of a supercomputer. So how do we fix that?
Well, the current approach uses something called mixture of experts, or MOE for short. Basically, imagine you have a specific problem you need the AI to solve. Instead of activating the entire massive model, MOE just calls in the experts, the parts of the model that are relevant to that specific task.
Oh, so it's kind of like assembling a specialized team instead of, calling up the entire army for a small task. That makes sense. Saves resources.
Exactly. But even with MOE, there are still limitations. You still have to go through a ton of data in the model's memory, and that search process, that takes time.
So it's like having a library with millions of books, but no card catalog to help you find what you need. You have to
Mhm.
go shelf by shelf, browsing every book just to find the right page.
Yeah, that's a great analogy. And that's really where this research we're looking at today gets interesting. It's a paper about something called UltraMem, and it aims to solve this very problem.
UltraMem. Okay. Sounds like it has something to do with memory.
It does, it does. Instead of doing that exhaustive search through the model's memory, UltraMem has a much smarter system.
Hmm.
It uses these things called ultra-sparse memory layers. They're kind of like a super efficient index for all the information the model has stored.
Oh, I see. So it's more like our library now has a super detailed card catalog that points you directly to the exact book and page you need.
You got it. And by cutting down on how much data the model needs to access, it makes the whole process much faster, like a lot faster. The paper actually claims that it can make these AI models run up to 6 times faster, even on your phone, and all without sacrificing accuracy.
6 times faster. That sounds almost too good to be true. I mean, what's the catch?
Well, like with any new technology, there are always trade-offs. But the potential here is huge. If UltraMem lives up to what the researchers claim, we could see a real shift in how we think about building AI, moving away from this idea that bigger is always better.
Right, so instead of just making these models bigger and bigger, we can make them smarter and more efficient. Now, okay, I like where this is going, but how does this Ultraman thing actually work? What's the secret sauce?
There are 3 key innovations they highlight in the paper. The first one's called Tucker Decomposed Query Key Retrieval. It's a bit of a mouthful, but essentially it's like giving the AI model a really, really efficient search engine for its memory.
So instead of rummaging through a jumbled mess, it can pinpoint exactly what it needs right away.
Right, exactly. The second innovation is called implicit value expansion. This one's a bit more complicated, but think of it like this. Instead of storing every single piece of information, UltraMem prioritizes and duplicates the most important stuff, making it instantly accessible.
Ah, so it's like having multiple copies of the most popular books in a library ready to be checked out immediately, no waiting in line.
Perfect, you got it. And finally, there's multi-core scoring. Instead of just relying on a single assessment of the information, UltraMem actually assigns multiple scores to each piece of information. That way it can make sure what it's retrieving is truly relevant and accurate.
So it's like getting multiple opinions on a book to make sure it's worth reading.
Yeah, a great way to put it. And, these innovations, when you combine them, lead to some pretty remarkable improvements in performance.
Okay, so it all sounds very promising, but you mentioned some trade-offs before. I'm curious about those. And also, how does UltraMem actually measure up against those MOE models we talked about? Maybe that's a question for part 2 of our deep dive.
Absolutely. We'll get into the performance data and compare those two approaches next time.
All right, sounds good. All right, so we've laid out the problem, these slow AI models, and we've got a taste of this potential solution, UltraMem. But the big question is, does it actually work as well as the researchers say it does?
Well, that's where things get really exciting. The team behind UltraMem, they didn't just stop at the theory, right? They actually put it to the test. They ran a whole bunch of experiments to see how it stacked up against the, current top dog, which is MOE.
Okay, so let's see the evidence. What kind of tests did they do?
Oh, they really put UltraMem through its paces. They tested it on all sorts of tasks that AI models are typically used for. Things like language modeling, answering questions, figuring out logical reasoning problems, even one of those comprehensive benchmarks that's designed to kind of assess overall AI performance.
So they weren't just looking at like raw speed, they were actually trying to see how well this thing could handle real-world AI problems.
Exactly. They wanted to see, okay, if you get this boost in efficiency, does that actually translate to better overall performance?
So did it. Did UltraMem live up to the hype?
The results were pretty impressive, I gotta say. Across all these different tasks, as the model size got bigger, UltraMem consistently either matched or even beat the performance of those MOE models. And it did all that while using basically the same amount of computational resources.
Wow. So not only is it faster, it's not sacrificing accuracy to get there.
It really is remarkable. You see, by getting rid of that memory bottleneck we talked about, UltraMem frees up the AI to use its processing power much more effectively. It's like imagine if you had a workshop where everything was perfectly organized, every tool you need is right at your fingertips. You can get so much more work done much faster.
Yeah, I'm starting to see why there's so much excitement around this UltraMem thing. But I remember you mentioned earlier that there were trade-offs. What were some of the limitations they ran into?
Yeah, one of the key things they had to explore was this balance between speed and accuracy. And a big part of that comes down to something called sparsity.
Sparsity. Okay, I'm not sure I follow.
Think of it this way. The sparser the model, meaning the fewer values it has to activate, the faster it can run. But if you make it too sparse, you risk losing some crucial information, and that can really hurt its performance.
Ah, so it's kind of like a balancing act. You want to be concise, but not at the expense of losing important details.
Exactly. And what the researchers found was that this optimal level of sparsity, it can actually vary quite a bit depending on what specific task you're doing and also what kind of hardware you're using.
So there's no magic formula. It's about finding the right balance for each situation.
Exactly. And the researchers are very open about this nuance. They're not saying UltraMem is this, perfect one-size-fits-all solution, but it's a big step forward, and it could be a real game changer for how we approach building AI in the future.
You know, what's really interesting to me is that UltraMem isn't just about making AI faster. It's challenging that assumption we often have that, oh, bigger models are always better.
Yeah, I agree with you. UltraMem shows that we can achieve some pretty amazing results with models that are actually leaner and more efficient.
And that has pretty huge implications, right?
Yeah.
Imagine if we could run these really powerful AI models on our phones, without them slowing down or draining our battery instantly. Think of what we could do.
Oh, the possibilities are really exciting. Real-time language translation that actually works seamlessly, AI assistants that are super responsive and actually helpful. It could change how we interact with technology on a fundamental level.
Okay, I'm getting pretty excited now,
Yeah.
but I know it's still early days. What are the next steps? What has to happen before we start seeing UltraMem-powered apps on our phones?
Well, there's definitely more research to be done. This paper is really a proof of concept. It shows us the potential of UltraMem, but to really unlock it, I think we need to do a lot more optimization.
So it's like we have this brilliant blueprint, but we need to figure out the best materials and construction methods to actually build the thing, right?
Precisely. And once we've worked out those kinks, we'll need to see how UltraMem actually performs out in the real world, outside the controlled environment of a lab.
That makes sense. This all sounds incredibly promising, but I can't help but think about the bigger picture here. If UltraMem really takes off, how could it change the world around us? That feels like a question that deserves its own, dedicated deep dive.
I think you're right. The potential impact, on society and on the economy, it's pretty huge. And yeah, it's definitely worth exploring further.
It's wild to think about, like, while we've been here talking about all this, kind of technical stuff, AI is already everywhere.
Yeah, it really is.
I mean, it's in our social media, it's recommending what we should buy, it's even filtering our spam.
Yeah, it's true. A lot of the time, AI is kind of working behind the scenes, shaping our digital world in ways we don't even realize. And with advancements like UltraMem, its presence could become even more, I guess, pervasive and maybe even more impactful.
So we've talked about how much faster UltraMem can make things and the potential for even better accuracy and, how it challenges that idea that bigger models are always better. But what does all this mean for, like, the average person? How could UltraMem actually change things?
Well, let's think about industries where language processing is like the core of what they do, like customer service, for example. Right now, it's all about waiting on hold or dealing with those frustrating chatbots. Imagine if you could just have a conversation with an AI that instantly understood what you needed and could actually help you solve your problem.
Now, that'd be amazing. No more repeating your account number like 5 times or getting stuck at those endless phone menus.
Yeah. Yeah, exactly. And it goes way beyond just customer service, right? Think about content creation. We could have AI tools that help writers come up with ideas, translate languages perfectly and instantly, or even create personalized lessons that adapt to how each student learns best.
It's like everyone gets their own personal tutor. That could be incredible, especially for students who, struggle in a traditional classroom setting.
Right. And then there's global communication. Instant and accurate translation could totally break down language barriers and, help people from different cultures understand each other better.
It sounds like UltraMem could help us connect and collaborate in ways we haven't even imagined yet. But with all this potential, I also can't help but think about, like, the downsides. As AI gets more powerful and more integrated into our lives, what are the risks we need to be aware of?
That's a really important question. As AI gets more sophisticated, we really need to think about the impact it could have on jobs and the economy as a whole. We should be thinking about retraining programs, support systems for people whose work might be automated.
It's like we're on the verge of this new technological era, and there's so much to be excited about. But we also have a responsibility to make sure these advances benefit everyone, not just a select few.
Absolutely. And that's a conversation we need to be having as a society. We need to make sure AI is developed and used ethically with safeguards in place to prevent things like misuse or bias.
So I think we've covered a lot of ground in this deep dive. We started with this, technical problem of slow AI, explored this really fascinating solution, UltraMem, and ended up, I guess, contemplating the future of AI and how it could impact the world.
It's been quite a journey, and I hope this discussion has given everyone, a better understanding of UltraMem, what its potential benefits are, and some of those important questions we all need to be asking as AI continues to evolve.
Yeah, absolutely. If you're interested in digging deeper into this, we've included a link to that UltraMem research paper in the show notes. We definitely encourage you to check it out and, form your own opinions.
And as always, we'd love to hear what you think. Come join the conversation on our social media and share your thoughts. What stood out to you? What are you concerned about? We want to keep this dialogue going.
Thanks for joining us for this deep dive into the world of UltraMem and the future of AI. Until next time, keep exploring, keep questioning, and keep learning.